Find the straight line distance between points A and D. In this problem, two curves in one straight line segment span from point A to point D. The radii for both curve 1 and curve 2 are provided in the problem statement. The length and bearing of the straight line segment CD is also provided. In the figure, the north arrow is pointed upward and the northing for points A and D are equal. To find the straight line distance between points A and D, we'll sum up the distances between points A and B prime, B prime and M prime and C prime, and C prime and point D, where the prime indicates a point's southward projection onto the straight line between points A and D. To begin, we'll first determine the length of segment C prime D. To do so, we'll first examine right triangle C prime DC. The problem provides the bearing of segment CD, and since points A and D have the same northing, line C prime D runs east-west, and angle C prime DC is 15 degrees. The problem also provides the length of segment CD, which equals 500 feet. Therefore, we can equate the length of segment C prime D to the length of segment CD times the cosine of angle C prime DC. After plugging in the known variables, the length of segment C prime D equals 483.0 feet. At this point, it would be helpful to solve for the length of segment C prime C, which equals the length of segment CD times the sine of angle C prime DC. After plugging in the length and angle, the length of segment C prime C equals 129.4 feet. Next, we'll determine the length of segment M prime C prime, which is the third term in the summation. We'll assign the point O2 to the center of the second curve and analyze the slice of the second curve swept out from point M to point C. The length of segment M prime C prime equals the radius of the second curve times the sine of angle MO2C. The problem states R2 equals 600 feet. Point M is positioned at the northernmost point of curve 2. Therefore, a line tangent to point M is parallel to segment AD. And since we know angle C prime DC is 15 degrees, we can use trigonometry to determine angle MO2C also equals 15 degrees. Therefore, the length of segment M prime C prime equals 155.3 feet. Next, we'll compute the vertical distance between point M and point C. We'll define a point C double prime by transposing point C westward onto line segment M prime M. Now we can equate line segment C double prime M to the radius of the second curve times the quantity 1 minus the cosine of angle MO2C. Plugging in these known variables, the length of segment C double prime M equals 20.4 feet. Next, we'll solve for the lengths of segment AB prime and segment B prime M prime simultaneously. To do so, we'll create point O1 at the center of the first curve. We'll also create point B double prime, which is the westward projection of point B onto the line O1A, and we'll also create point B triple prime, which is the eastward projection of point B onto line O2M. Since line segment O1A and line segment O2M are parallel, both running in the north-south direction, angle AO1O2 and angle MO2O1 are equal. For simplicity, we'll label this angle angle I. The lengths of segment AB' and segment B'M' are functions of the radii of the two curves and the sine of angle I. To find angle I, we'll equate the vertical line segments B'A and B'M to the length of vertical line segments C'M plus the length of segment C'C. Earlier in this problem, we solved for the lengths of line segments C'M and C'C. We can solve for the length of segment B'A and B'M using trigonometry. Substituting in these values, simplifying the equation, and plugging in the values for radius 1 and radius 2, angle I can be solved for explicitly and equals 25.0 degrees. Plugging this value in for I, as well as the radii, the lengths of segments AB' and B'M' equal 422.6 feet and 253.6 feet, respectively. Plugging in these two values, as well as the other lengths of segments M'C' and C'd, the straight line distance between point A and point D equals 1,314.5 feet. When reviewing the possible solutions, the answer is D.